Ladies and gentlemen, my name is Bassam Dali. I'm the professor at the School of Mechanical Engineering, and I'm also the Deputy Director for the Center for Energy Technology, and I will be your MC this evening. Welcome to the inaugural Luxton Memorial Lecture, named after Emeritus Professor Sam Luxton, who passed away last year at the age of 81. Before we commence the proceeding, I would like to acknowledge the Kaurna people, the original custodians of the plains that the University of Adelaide campuses are built, and pay my respect for the elders, past and present. I would like also to convey the apologies of the Deputy Vice-Chancellor of Research, Professor Mike Brooks, and the Executive Dean, John Barnan, who couldn't be here with us tonight. And I'd like to acknowledge the members of the Center for Energy Technology Board who are here with us today, and thank them for their continuous support. This lecture series was established to honor Sam's contribution to science and to the society in general, and more importantly, to propagate his vision for a cleaner and prosperous Australia through innovation and responsible energy policy. You will hear more about Sam's legacy later from our speakers tonight. We are grateful to the Luxton family for endorsing this lecture series and for their attendance this evening. The family is represented by Sam's wife, Jeannie, his son, Ben, and his nephew, Dr. Duncan Ward, and his wife, Lynn. The family had a lengthy and well-established link with the University of Adelaide, in addition to Sam's contacts and contribution to the university. Ben's maternal grandfather was Professor Joseph Carney Wood, who was a former professor at the University Botany Department. This may explain Ben's interest in science rather than engineering, I guess. And Duncan's supervisor for his PhD was no other than Uncle Sam. Sam was Duncan's supervisor. For those who don't know Sam, I will briefly talk about Sam's life and career. You will hear more again from Gus later about Sam. Sam was born in Rockhampton, Queensland in 1933, went to Geelong Grammar School from 1939 to 1951. He graduated with a Bachelor of Engineering with honours from the University of Adelaide in 1955 and worked as an engineer for a few years before enrolling into a PhD at Queen Mary College, London, where he graduated in 1960. This work in the industry may explain later on Sam's interest in engineering rather than just science as such. Sam returned to Australia in that year to take up a position as an academic at the University of Sydney, where he stayed there until 1974. In that year, he was offered a professorship here at the School of Mechanical Engineering at the University of Adelaide, and where he stayed in here until he retired in 1999. The university awarded Sam an emeritus professor title upon his retirement. In fact, I arrived at this university in 1998 to not fill in for Sam, nobody can, I think, but at least to teach his courses when he retired. The program tonight includes a video. It includes two talks, and there will be a facilitated discussion towards the end, and you are encouraged to participate with it. We are hoping to finish tonight's proceeding at towards the 8:30. Our first speaker tonight will address us via recorded video. We are privileged to have the Chairman Emeritus and Chief Scientist of the Rocky Mountain Institute from Snowmass, Colorado, Amory Lovins, who knew Sam well and collaborated with him, to say a few words at the start of this lecture. I'll play you the video in a minute. Amory had a long and very impressive career as an energy practitioner. This is what he calls himself. He is considered the leading authority in energy, especially its efficient use and sustainable supply, and a fertile innovator in integrative design and in super efficient buildings, factories, and vehicles. His contribution has major impacts in more than 23 countries and has affected millions of people. Nothing, I would say, will make justice to Emery's contribution and career. And perhaps I can sum it up by saying that in 2009, he was named by the Times among the world's 100 most influential people, and by the Foreign Policy as one of the 100 top global thinkers. We'll play with a video from memory. I now would like to introduce Professor Gus Nathan. It's interesting. Gus's name is Graham, of course, and apparently Sam called him Gus. He saw him walking in the corridor and said Gus, and from there on, his name's changed. This is power Sam had. So I actually knew Gus's name almost 2 months after I joined in here, that his name is actually Graham. Same with Sam, of course, his original name is Russell. So Gus was Sam's student, and he's the founding director of the Center for Energy Technology here at the university. Gus completed his PhD in 1988 under the supervision of Professor Luxton. Following this, he worked closely with Sam and was mentored by him until Sam's retirement. Key partnerships including the development of low-NOx gyrotherm burner and the flame of the Sydney Olympic relay torch, which they co-invented along with others in the group here in Adelaide. Gus is the recipient of an ARC Discovery Outstanding Research Award. He has more than $20 million in research funding. He works with energy technologies spanning combustion of fossil and biofuels, concentrating solar thermal, geothermal energy, wind power, energy storage, and hybrid technologies. He works closely with industry and in the application of science to solve real-world challenges, including with advanced laser techniques. He has published widely with more than 120 publications in leading international journals and 250 peer-review conferences, and is named on more than 10 patents. Gus will talk about Sam's legacy. Please welcome Gus.
Thank you, Bassam, and thank you all for coming along today to this inaugural lecture series for the legacy of Professor Sam Luxton. As Bassam mentioned, we're going to talk about the legacy a bit more, which you've already heard is very substantial. I had the privilege and honour of working closely with Sam, and hence have entitled this Clean Energy Technologies from the lab to industry, because that's what I guess marked his career as being distinctive from many others, as he worked from the fundamental science that underpinned right through to the application. Before so, I would like to, there are many others, of course, who have contributed to the work that I'll talk about today. Bassam, who spoke earlier, Peter Ashman is representing some of the work I'll talk about today, Richard Kelso with a lot of the Olympic flame, Greg Mether also from the executive, and Jordan Parham, who have both had all had a role in the organising and the work I'll talk about today. So Sam left many legacies which are ongoing. He drafted an energy report to the Prime Minister in 1977, which led to the establishment of NERDC, which was the National Energy Research, Development and Demonstration Council. So one of the things that was distinctive in what he recommended was that it's important to fund research not only at the early stage but in the demonstration stage, and that evolved eventually into a number of series, including to what is now ARENA, the Australian Renewable Energy Agency. Within our university and centre, he established the interdisciplinary research group with Professor Keith King, who is here today from School of Chemical Engineering, to form a strong group that linked the mechanical and chemical engineering research in combustion, which eventually became even more interdisciplinary in the Centre for Energy Technologies, which now also includes electrical engineering and chemistry, as well as others, including in economics. Two of the main technologies, patented ones that he were particularly significant, are not just individual components, but a series of family of components. The gyrotherm low-NOx burner, which I've been involved with, and the low-energy air conditioning, which you heard about from Professor Amory Lovins, from which not only was a technology, but he also then was co-founded a company, which I'll say a bit more about shortly. But within the university, he established a culture of integrating science and technology, not just doing science because it's interesting, but although that's of course critically part of it, and if you saw him walk around talking about the gyrotherm burner, his arms are waving around and he was very excited about it, but also the underpinning science that was needed to solve a practical problem and make a difference, make the research more predictable and more reliable. So his approach, if we summarise it, was to engage with society, to understand the challenges, and he was on many boards and programs, of which a few are listed here. Then to devise innovative solutions to the major industrial challenges, establish the partnerships with which to implement them. So working with industry and other collaborators around the world, and you saw Professor Amory Lovins talking about some of those collaborations internationally. Establish strategic research programs to identify the new science that's needed to underpin the technology, and then inspire his team to meet the challenges. And all of those of us who have had the privilege of working with him knew that he was definitely an inspiring person. He had absolute confidence. I'll say a couple of words about the Danco company, which he co-founded, which has since been taken over by Mestec, a multinational corporation. The Shaw method, which what it became known as, which Professor Lovins spoke about, the low face velocity, high coolant velocity, which increased dehumidification by about 25%. But in addition to that, there are a series of other technologies, including he developed an induction cooling system with a 5-lobed nozzle, which was also patented, and that became one of the key components in the Danco chiller and the chilled beam, which is shown here. This was co-founded with Dr. Vladimir Petrovich, whom he also supervised in his PhD, and the company was formed in 1995 and won multiple international awards, and then eventually moved to the USA and was bought out by Mestec. And in honour of his contribution, the Luxton Reed Centre was established in 2012 and is ongoing. So there's a few of those of us, perhaps one of the technologies that was particularly renowned for a period worldwide, and some of the members of the team are here. I remember probably one of the words which Sam spoke, which will go down in history, was, "Sure, we can make that thing burn underwater." And we worked in partnership with FCT Combustion, who are also represented here today. And David Retallick is shown in this image here. And here's Keith King from the chemical engineering, Richard Kelso, who did a lot of work on the project. Steve Hill is also here tonight. And so we established a project to meet the challenge, and the torch did have a significant contribution. It reduced the number of flameouts by 10-fold compared to its predecessor, and reduced emissions of the net global warming emissions by 60%. And this technology also became a major platform for partner company FCT, who has, I've mentioned, is here today, and has formed with a series of other technologies, has been implemented in every Olympic Games in one form or another since the year 2000. The low-NOx gyrotherm burner also had substantial technology benefits, achieving 40 to 60% reduction in NOx emissions in rotary kilns, fuel savings of 3 to 10% with an increase in production of typically 5%. Of course, these vary from installation to installation, but they're typical numbers. And it has also become a major technology platform for FCT, who is still based in Adelaide, with installations in more than 30 plants worldwide. But this was underpinned by a very strong research base that Sam was pivotal in establishing and then contributing throughout its period, although it continued beyond when Sam retired, with some 17 PhD theses and more than 60 journal papers and $8 million in joint R&D funding, with a lot of that was in partnership with FCT Combustion and a range of other sources, some of it with just government funding. This is one of the flames you'll see there. Characteristic features are the highly luminous colours, which we ended up discovering is attributable to the increased amount of soot in the flame, although it burns out, which increases the radiation, drops the temperature from the flame, which is what reduces the emissions of the nitrous oxides. And this legacy then evolved into, beyond the research group, to now what is a centre in energy technology, with combining multidisciplinary research from 40 staff, including academic and research, 50 postgraduate students, typically 100 publications, which is multidisciplinary and closely engaged with industry, as you can see from these numbers here. And the main areas that we now prioritise are in sustainable fuels, sustainable power, and sustainable networks and homes. And within this, the legacy, I guess, continues in the technology application. So you'll see there are a lot of patented technologies in hybrids, in a range of different ones that I won't name them all, from wave power, wind power, and solar thermal linking. So starting from the combustion, we've then expanded out into other thermal industries, including the concentrated solar in particular. Sustainable fuels, I'll say a bit more about later on, is particularly important because it has potential to add to Australia's resource sector. So we have a number of technologies there, including a partnership with Muradel in microalgae production to liquid fuels, and another one with Hydricity SA. Then there are a number of industry partners in the energy storage with SA Power Networks, Solar Storage and Zen, in the sustainable networks and homes, with energy storage technology being a key future technology of the future. I'm just going to say a couple of words about one of the technologies, which is, although Sam wasn't directly involved in it, it really captures some of the things that he was linked to, his approach. So this, as in with the air conditioning technology, which Professor Lovins talked about, is a fairly simple concept, but going into detail has got a lot of science behind it. So a conventional solar tower system has got heliostat fields, some kind of receiver, and then increasingly solar thermal storage, which is one of the key drivers for this technology, because the storage of energy in solar thermal is much cheaper than with electrical systems. However, because the solar resource is intermittent, most conventional systems have got a boiler to back that up. So the concept that we derived is quite simple in principle, is to integrate this boiler into the receiver directly. And that's shown here. There's no boiler here. It's integrated. Now the combustion is introduced into here. It's quite a simple concept and has some benefits, which I'll mention shortly, but it also introduces some scientific challenges, because now the flame, when it's run in the mode when the solar resource is a bit lower but there's still enough of it, there's still very high flux radiation impacting on the flame, which introduces some novel and some challenging scientific issues which we're also looking at behind that. So this is the kind of device, is schematically shown. So there's a cavity receiver with a combustion system introduced, which can run when the sun isn't shining. So we just keep one system running hot all the time, and of course there's energy recovery, etc. The concept is quite simple, but the benefits can be quite significant. We've just completed a series of analysis, and we're estimating that the reduction, when you account for the full issues of the intermittency, the capital cost is reduced by about 21%, the levelized cost of electricity by about 12%. This is compared to the solar thermal hybrid with a separate boiler. Reduces the fuel use and CO2 emissions because you keep one system hot by between 10 and 20%. But solar thermal can be used for a range of other applications. It's simply a way of replacing the heat that's traditionally driven by combustion. Can also be, this is a photograph of a power tower in operation, and this heat can be used for driving any of the conventional thermal processes. Well, a large number of them can be driven by concentrated solar. And if you integrate it with a hybrid system, you can then maintain a system that runs all the time. So the conventional gasification process, which can be used, for example, to generate diesel fuel, is typically done by burning some of the fuel with oxygen to generate the heat that's required to react the feedstock, which could be coal or biomass or some blend thereof, to react it with water, needs heat. That heat, if it's provided by the solar, we don't need to burn as much fuel, we get less product, and we get more of the fuel goes to the output because we're not a parasitic loss of generating the heat, and we avoid this CO2 in the product. So there's many advantages from this approach. So my final comment is now picking up perhaps on the question that we're trying to pose in today's seminar, which will be followed on by our main speaker, Tony Wood, after this, and this will perhaps lead into the discussion, which also picks up on some of the themes that Sam spent his life addressing. The question we're wanting to raise in the discussion is Australia energy technology leader or follower? And Professor Luxton showed that Australia can be a leader in innovative technology, and there are many examples around the country. Two of them that he's had a role in are two leading technology platforms, one in combustion, one in air conditioning, which have been implemented in industry. We know that in Australia, to have leadership throughout the technology supply chain is a challenge, because most of the big energy technology companies are offshore, be that the Siemenses, the GEs and the like. So there's much more of the supply chain in the energy technology offshore, which is why many technologies may start in Australia and then eventually move offshore, as indeed did the air conditioning technology of Danco. So the comment is that global leadership is easiest where there's a competitive advantage. So what are some of the competitive advantages in Australia? Some of them are in agribusiness, and there the biofuels offers an opportunity. In both traditional resources, such as fossil fuels, but these can be made cleaner by upgrading or reprocessing to give lower CO2 fuels. And the slide I showed earlier was an example of that. But also in renewable resources, but in things like exporting, for example, concentrating solar in a liquid fuel. Australia has also got good resources of solar thermal. If we blend these together, there's a reason for maintaining the technology base in Australia. And there's significant opportunities in a range of high-tech, clean fuel sector where we can add value to Australia both in the product and in the technology itself. So these are some comments that we maybe pick up later on in the discussion after Tony. Thank you.
Thank you, Gus. Something Sam taught me is that academics don't retire. When I first arrived in here, he was retiring, and yet Sam wanted to learn how to use this new software, and Sam wanted to do the first aid course so he could go to the lab. And as a junior academic just starting, thinking, is this where I'm going to be at 65, looking to start again? But then it actually, the question remained with me for a while, and then realized it's a disease in a way. Academics never retire. And I felt sorry that Sam's health didn't actually allow him to continue to be active and so on, because he enjoyed it quite a bit. Our next speaker is Tony Wood. He's the Energy Program Director at the Grattan Institute. Tony has led the Grattan's Institute Energy Program since mid-2011. Since then, he and his team have delivered 7 major reports on energy and climate change, and he has developed strong profile with governments and industry, and is a regular contributor to major media in key energy issues. From 2009 until mid-2014, he also had a role as Program Director of Clean Energy Projects at the Clinton Foundation, advising governments in the Asia-Pacific region on effective deployment of large-scale, low-emission energy technologies such as solar and carbon capture and storage. Prior to these roles, he spent 14 years working at Origin Energy in senior executive roles, covering retail and LPG line management and corporate affairs. In 2008, he was seconded to provide an industry perspective to the first Gano review. He has built widespread relationship within the energy sector and is an advisor to government. Tony would talk about Australia's energy future, technology leader or technology follower. Please welcome Tony Wood.
Good evening and thank you, Bassam. I guess I was musing as I was listening to some of the speakers, and my mind would often have come up a peculiar direction because I was pondering as to how one of Australia's leading engineering scientists ends up being named after a cricketer. I wondered how long it would be before a cricketer gets named after a leading engineering scientist. Maybe then we'll have come some way in recognising the role of science and technology and its contribution to our society. Let me also pay my respects to the traditional owners of this land and also to the family and colleagues of Professor Sam Luxton. I'd like to thank the University of Adelaide School of Mechanical Engineering and the Centre for Energy Technology for the opportunity to present this address to you this evening. I never met Professor Luxton. However, I've spoken with his colleagues on several occasions and I've read a little about his life and work. And while you can only be impressed with the range of things he did, and now having heard both from Amory and Gus even more so, what really captivated me was something that appears to me to be a central theme of his work, and that will become the central plank of what I'm about to talk to you about this evening. It may be that my view is somewhat tinted by the fact that in the mid-1970s I ran away screaming from academia. Admittedly, in the 1970s was a pretty bad period for chemistry departments, so maybe I had a good excuse. But what fascinated me then and still does is how many people I went through university with and academics I've met since then don't seem to have that interest in making sure that the research work they do actually ends up adding to the sum real total of human knowledge and delivers something. And that's something which I think is very central to what, as my understanding is, Sam did. In my case, I began life as a scientific academic and very quickly became an industrialist. In only recent years, I've actually returned to this issue, thinking about how do you integrate science, engineering, policy, government and technology. And in particular, the work that we do at the Grattan Institute is focused on how do you develop the appropriate policy settings to ensure that we actually get real investment in real technologies that make a real difference. So let me begin with 2 broad questions. The first is, what is the role of science and engineering in underpinning our future economic prosperity? And the related issue in these days is, how does science and technology contribute to addressing what's been described as the great moral challenge of our time? I think it's true that fundamentally our economic prosperity, in answering the first question, does rely on the delivery of reliable and affordable energy. Demonstrably, the current system in Australia has delivered that for many, many years. The harnessing of energy is what makes possible the world that we all live in and the world as we know it. In the first half of the 19th century, Sadi Carnot, who was the son of one of Napoleon's war ministers, observed, in his view, that one of the reasons the British were so successful in winning the Napoleonic Wars was because of the way they applied technology, and in particular the steam engine. And he set about understanding this better, and he delivered what was still recognised as one of the first systematic analysis of the role that energy could play in harnessing and supporting the future of mankind. His work contributed to the second law of thermodynamics, and the Carnot cycle, of course, became a fundamental staple of modern engineering. The steam engine enabled mankind for the first time to break the shackles that have been created by the limits of the muscles of man and beast. And for the next couple of centuries, the role of affordable and reliable energy continued to grow, almost unabated. In many parts of the world, that role continues. You only have to witness the extraordinary increase in the use of energy and, of course, the associated greenhouse gas emissions that has gone with the growth spurt in the Chinese economy in the first decade of the 21st century. The same story played out in Australia, a country blessed with many energy resources. Energy supply has been and remains reliable. Australia's generators, transmitters and distributors have clearly delivered, and policy has developed in a situation that's gone on pretty much independent of whether those assets were owned by governments or the private sector. And two examples to me demonstrate the success of that point. Firstly was the building of what are now the very large fossil fuel power stations that were built in Australia generally in the 60s and 70s. And the development of the technology at that stage took an interesting twist, because I remember talking to an engineer in Victoria who explained to me that in the late 1960s there was a project to build a nuclear power station in Victoria. And the thing that killed it off had nothing to do with the sort of issues about which people are concerned today. What killed it off was the sheer economics. People worked out how to build thumping great coal-fired power stations really cheaply and produce electricity really cheaply. And arguably, courtesy of grandfather's axe, those self-same power stations are continuing to develop and deliver reliable and relatively cheap electricity today. The second thing that I think illustrates the way technology can change was the competition reforms of the late 1990s and the construction of the interstate transmission lines. And that technology effectively added additional quantum of power generation to the grid, and by increasing the dispatch window for the power stations and increasing the productivity of those power stations to levels that had never been seen before. It is only recently that energy affordability has actually been challenged, with average electricity prices in the last 5 years increasing in real terms by about 60% and average gas prices increasing in real terms by about 35%. Of course, I should point out very quickly that the primary cause of those increases is not carbon price or renewable energy technology. The primary cause has been fundamentally a failure of the regulatory model. And of course, that's not a topic that I intend to explore any further this evening. But I would argue that this energy system could continue to supply reliable and affordable electricity for many decades ahead. As our Prime Minister said, coal has been good for us. But now we have a difficult problem, a somewhat tricky problem. It turns out that the burning of fossil fuels to deliver reliable and affordable energy has been achieved at a cost that we've simply not recognised, partly because markets are not very good at recognising environmental or social costs. The cost has been creeping up on us, and today it's actually not much different from if we allowed nuclear power stations to be built and didn't bother about containing radioactive waste. Effectively, what we've been doing is implementing a very significant cross-subsidy from the future to the present. And one of the questions is, will those who come after us, will our descendants thank us for the cross-subsidy that they will be paying for our benefit? Now, I don't intend this evening to explore the science of climate change. What I want to do is just draw a simple connection back to my central theme. The world's governments have agreed that we should aim to limit global increases in temperatures associated with climate change to no more than 2 degrees centigrade. This translates to a greenhouse emissions concentration of something of the order of 400 to 450 parts per million of CO2 equivalent, and that then can be calculated to represent the global emissions budget. And under that budget, published by the International Energy Authority only in the last couple of weeks, the world can emit about 1,000 gigatons of CO2 equivalent from 2014 ever. Ever. The world can spend that budget sooner or it can spend it later. But it is a fixed budget and it is a finite budget. At present, the current way we're going, the whole budget will be used up by about 2040. Clearly, that is not where we need to go. On the most widely accepted allocation of that budget, the developed countries, of which Australia is one, needs to reduce our emissions by about 80% below 2000 levels, around that, by the mid-century. And for Australia, that means decarbonising an energy system that I've just described quite positively, but an energy system that has to fundamentally change within about 35 years. The scale is indeed daunting, but we are not alone in this task, despite what some would try and suggest. Others have already moved or are committing to do so, and only last week the United States and China reached an historic deal on climate change, an agreement, of course, that top conservative politicians in the United States and some in Australia have criticised. The deal ups the United States' commitment from a reduction in their greenhouse gas emissions by about 17% below 2005 levels by 2020 to a reduction of between 26 and 28% below 2005 levels by 2025, and commits China for the first time to a goal of peaking its carbon emissions and getting 20% of its energy from non-fossil fuel sources by 2030. Now, the political journey for the United States will be just as difficult, if not more difficult, than it's been for those who've tried to go down this route in Australia. But the commitment is there and it's tangible. For China, the delivery of this high-level commitment, integrating multiple emissions trading schemes, dealing with significant airshed pollution, is indeed daunting, particularly as they take a country of well over 1 billion people into a modern economy. This will truly be a task of awesome proportions. But for Australia to make a transition to a near-zero emissions energy system while maintaining reliability and affordability is as daunting as anywhere in the world. So how might this happen? Well, one of those reports that was mentioned earlier that we did at Grattan back in 2012, we looked at 7 technologies that generate electricity with near-zero emissions and which already are developed enough to be considered as plausible to make a material contribution by the mid-century. They are wind, solar PV, geothermal, nuclear, concentrating solar power, carbon capture and storage, and bioenergy. We assess the current performance and future potential of each technology and what would need to change for it to be deployed at large scale and at sufficiently low cost for it to make a big difference. Each of them could materially contribute to Australia's future energy mix. All face obstacles to achieve their full potential. And when you consider them all in total, Australia has no quick fix and no easy choices. Despite current projections, it's possible that none of these technologies can produce power at the scale and the costs similar to today's electricity. In other words, existing policy will not on their own produce the transformation that we need. The central policy element that will ultimately deliver the change must be a carbon price. Labor's emissions trading scheme, which translated into a fixed price for the first couple of years, was an example of such a scheme. The current government's direct action plan may be able to create a version of a carbon price. That challenge remains for the government. But a carbon pricing scheme by itself will not be enough to cause the technology transformation that's required. So what's to be done? Firstly, to minimise uncertainty about future financial returns due to regulatory changes, the government must get the core design and the governance structure right. This becomes an area for economic policy nerds, but it does include the process by which targets are set and programs reviewed. And you only have to look at the almost poisonous debate that's gone on in relation to the renewable energy target over the last 6 months to see how badly that can be done. So wherever we start, the way we think about designing these markets must be done well. To ensure that markets work properly, however, governments must also do other things. That is, they must address market failures and they need to address barriers to the development of technologies. So typical barriers would include transition connection hurdles for remote renewable energy and the removal of subsidies to incumbent technologies. Now, some of you may think there aren't all that many around. Well, I would just point you to the support that the Queensland Government this week announced that they would give to a coal mine in that state as an example of how not to do and not to drive the sort of transformation that is required in Australia and in the world. Yet even if these barriers are removed, it remains unlikely that enough funds will be invested in the short term to give our low carbon technologies a chance to deliver. And the reasons are many. Early movers faced higher costs than followers. Finance costs are higher for technologies that are relatively undeveloped. New infrastructure and regulatory frameworks have to be delivered in many cases, imposing delays and costs on early movers that followers don't have to pay. Resource mapping in areas of solar and geothermal energy is inadequate. And some technologies, such as carbon capture and storage and nuclear energy, simply don't have strong public support in Australia. Early movers get little reward for incurring these costs. Because electricity is an undifferentiated product, innovations do not earn more, and intellectual property may not be defensible. Early movers cannot bank the full value of protected high long-term revenues for low-emission energy technologies because government policy on climate change and energy is inherently unreliable. And as a result, the private sector investment will deliver less than the best outcome for Australia. And that provides the underpinning rationale for governments to support research and development in areas of national interest and demonstration and early stage deployment of a suite of technology options. It is not easy for governments to steer a course between let the market rip on one hand and picking winners on the other. But it is that difficult task that governments are going to have to address if we have any chance, I think, of developing and delivering the low emission technologies that we need. Now, new and evolving technologies are already changing the way we use energy and the price we pay for it. This provides opportunities and challenges. Some of you may be familiar with the work that CSIRO headed up over the last couple of years and published in a document called Future Grid. It highlighted the possible scenarios that could develop as various choices are made by consumers and by investors. Such choices also drive the forces of destructive capitalism. And destructive capitalism is actually one of the most positive things we can get because that's the way markets cause change. That's the way game breakers can actually make a difference. And you only have to look at what's happening in our current power system to see it happening. Right now, as a result of falling consumer consumption, as a result of high prices that I mentioned before, and partly as a result of forcing a new supply through the renewable energy target, we actually have significant oversupply. And as a result, wholesale electricity prices are very low, and some fossil-fueled power stations have already been mothballed or slated to close. Now, that's exactly as it should be, and anyone who listens to the calls of those companies who say they should be helped through an orderly withdrawal of their capacity from the market should think again, because I can't see anything wrong with the disorderly withdrawal of such capacity from the market. As I've said, the technologies that we see today have served us well, but they might not deliver the transformation we need. In recent years, we've seen interest in postulating technologies and what they can do, what their cost might be in the future, and what technologies might be the winners or losers in an energy transformation. Economic models have become the way in which people prove one theory or another about what our energy mix should be. I must admit, when I look at the output of these economic models, my conclusion is a bit like Galbraith, who said the only thing that economic modelling has ever done is to give astrology a good name. Equally, we have seen policies that in greater or lesser ways do pick winners. And to some extent, the renewable energy target and various state-based solar PV feed-in tariffs are good examples of what happens when you pick a technology and how much that ends up costing consumers and not necessarily delivering a low-cost pathway to a low-emission future. To me, this is like looking at the problem the wrong way around. The first thing should be to decide on the big issues, what we want, and that means internalising the environmental externality. It means recognising the environmental cost of unabated greenhouse gas emissions. If we then get that policy setting right, then scientists, engineers, financiers and investors will deliver the outcome. That doesn't mean everything will be rosy. Technology, finance, policy and all these things are very unpredictable, and they can play out in all sorts of unpredictable ways. And any policy that tries to predict the future will come unstuck, because it will almost certainly get it wrong, either in relation to policy as things develop or in relation to technology. And you only have to look at the positive side of how quickly solar PV costs have come down and how wrong governments got that, and at the same time how the great hope of Australia's renewable energy, namely geothermal, hasn't got very far at all, to see how wrong it would be to tie our energy technology future to picking particular winners. But as a real example of how technology can respond to markets, you only have to look at the shale gas revolution in the United States. It was only a few years ago that high prices and continuing demand meant that people were building LNG import facilities into the west coast of the United States. And to some extent, I think it was Pierce Brosnan, the actor, who helped stop BHP Billiton building a facility in California, and maybe they should be glad for that. Because now what we're seeing is, as a result of the application of three technologies, three-dimensional seismic, horizontal drilling and fracture stimulation, we've seen an absolute revolution in shale gas. The United States will almost certainly become energy independent and is now looking to export liquefied natural gas into Asia. So things can be very dramatic. In Australia, we have particular circumstances. We have just about every form of primary energy that we can dream of, with possibly the exception of any more large-scale hydro, and we are increasingly dependent on imported liquid transport fuels. And we are a long way from global energy markets. Maybe it is the case that our sunshine has driven solar, but we do have a history of great science in solar energy. But great science is not always enough. The company I used to work for, Origin Energy, worked closely with ANU scientists to develop a technology known as Sliver and built a sophisticated development facility here in Adelaide. At that stage, the total Australian demand for solar was about 10 megawatts. And the manufacturing facility operated by BP at Homebush in Sydney was about 20 or 30 megawatts, and that was global scale, 20 or 30 megawatts. And now we're seeing production facilities well over 1,000 megawatts being built in Asia. The combination of access to global markets and changes in the silicon supply chain meant that even taking that technology to the United States and closer to the markets, it ultimately failed. Now, that is not to say that technology support is a bad thing. Another example on the other extreme is the extent to which Australia was able to adopt and innovate around LNG technologies. I've already mentioned what happened in the United States, but we've known about coal seam gas in their coal seams in Australia for many, many decades. And in the early 1990s, a number of American companies came to Australia with their coal seam extraction technologies and spent hundreds of millions of dollars in looking to extract coal seam gas from those coal seams in Queensland. They all failed and they all walked away. But some Australian companies stayed around and they continued to develop the technologies. They applied them to Australian geology and Australian geography They innovated around the technology. They did the sort of thing that I would think Sam Luxton would have done if he'd been there. And as a result, we're now seeing $60 billion worth of investment being invested in Queensland, and within a few years, most likely, Australia will be the largest exporter of LNG. Ironically, one of the companies, American companies, that is now part of one of those projects is ConocoPhillips, which is one of the companies that walked away in the 1990s. So Australians do have something to offer in a whole range of areas. So in Australia in 2014, what does the landscape look like for the development of the low technologies that we need? And what should we do to ensure that these technologies go through the phases from research to development to demonstration and deployment? How will we get them there? There are, of course, many complicated and interwoven issues between science and engineering and between academia, business and government. And that's at the core of what has to be done. The first thing is that today we have neither a credible, long-term, predictable carbon price nor a clear rationale for technology support. Emissions trading schemes and the current government's emissions reduction fund are a good start, although you'd have to say there's an awful lot of detail to be put in place around the latter. I'd also say that the renewable energy target in this sense was also not anything except a fatally flawed policy. My key point is none of these provide a framework to deliver new low emission technologies that could be the lowest cost in the future. What they tend to do is take off the shelf what's already there. That's the easy thing to do. In the 1970s, the federal government introduced a research levy of 5 cents per tonne of saleable coal on Australian coal producers and created NERDIC that Gus referred to before, and I understand that Sam contributed to that. The Australian Renewable Energy Agency, ARENA, is the current manifestation. Sadly, despite bipartisan support, the future of ARENA is highly uncertain. I suggest this comes not so much from the fundamental role that ARENA is expected to play in developing and being a cradle for early stage technology development, but is more to do with the way in which the funding support for ARENA was structured. That is, on budget. So when the Abbott government came into power, they had some serious challenges with respect to budget. The first thing to do was, what can we cut back? They're in the forward estimates. And ARENA happened to get caught up in all of that. I must say, have some difficulty with ARENA because it seems to me, and I still can't understand why, it seems to be illogical, and I can't understand why we don't seem to be able to embrace low emission technologies rather than a fixation with technologies that are only always described as renewable. The biggest challenge I think facing ARENA therefore is the way it's funded, and maybe something more like NERDIC would be a more appropriate model to provide funding that would have some degree of continuity into the future. The second body in this space is the Clean Energy Finance Corporation. Again, the exclusion of technologies to reduce emissions from coal and fossil combustion seem to me somewhat illogical. More fundamentally, I'm not sure that the robust rationale for the CEFC was ever established, because in some ways it was a bit of a compromise as part of a deal between Labor and the Greens, and in some ways all it does is fill a gap that really should be filled by having a robust carbon policy in the first place. Now, that's not to say that the Clean Energy Finance Corporation isn't funding some really interesting things and has some very clever people running it. I just don't think it's an appropriate use of public funding. So, if we're going to deliver the energy technologies that will underpin our future economic prosperity, what do we need? We need to be clear on at least 4 things. It's very tedious in some ways to come back to the central argument, but the first priority must be to move beyond a 2020 period into a credible and predictable climate policy with bipartisan support. Now, you'd have to say, where on earth would anyone think we could get there from where we are today? But if we don't, then I would suggest we're going to go around in circles and continue to have a dog's breakfast of energy and technology policy for a while yet. The second thing we need to do is establish ongoing and well-funded support for technology research in a way not subject to the vagaries of the annual budget cycle. Thirdly, governments must address some of those barriers and market failures that could impede the development and the deployment of these technologies. And fourthly, and the one that's probably the most difficult, is how do we create, and we need to do this, how do we create a technology bridge for the development and early stage demonstration of a suite of low emission technologies. In his 2011 book, The Quest, the Pulitzer Prize winning author Daniel Yergin wrote extensively about the history of and evolution of energy through to the present. The title of the book, The Quest, relates to the search for sufficient, affordable energy that can be available on a sustainable basis to meet the energy needs of the decades ahead. The challenges, particularly when the scale is considered, are indeed daunting, but the book ends on a positive note, and so will I. It is a note that connected me with the very cursory understanding I have of the life and work of Sam Luxton. The generation of knowledge and the application of science have become a worldwide endeavour, and the resource base that is creative innovation is growing very fast. There are many uncertainties, political, social, economic and scientific, and in that uncertainty it is essential that we create the conditions for nurturing creativity and supporting its flourishing. And this will be the critical resource, because at the heart of the quest, it is as much about the human spirit as it is about the technology. And that is why the quest will never end. Thank you.
Thank you, Tony, for this really inspiring, informative and really befitting lecture. To honour Sam, he would have been really pleased to hear you say these words. The next part of this evening will be a little bit of discussion, so I'm going to introduce Susan Jeans, who many of you would know. She used to be a Member of Parliament, and she's been involved in energy institutions or organizations for a long time. She also heads the Centre for Energy Technology Advisory Board. So, Susan. And I'd like to invite the two speakers also here to the chairs so we could start the discussion.
I think we've got 20 minutes, so I think we'll have a few questions to the presenters tonight, and then we'll open up the floor. So I'd ask that you make your questions rather to the point, rather than too many mission statements. And guys, I'd ask you to do the same. Keep your answers as succinct as you can. Tony, I'd like to ask you, your topic for tonight was Australia's energy future, technology leader or follower. I'd like you to tell me how you would have answered a Treasury official who said to me a couple of years ago, why does it matter? Why shouldn't we just be a technology follower in Australia and let other countries pay for the development of the technologies?
I think my central part of that answer is that we'll do both. There will be areas where it will make no sense for Australia to try and be a leader in the technology. There may be cases where, for whatever reason, we do develop some interesting science, but almost immediately the technology itself goes offshore. That's not a bad thing. That's exactly what should happen. There'll be other areas, and Gus referred to a few of them, where we might very well take a leadership position. And I think the challenge for government is to actually start to address how we go down that path, because it's very easy to say, we'll pick this winner or that winner, and we know what happens then. Usually they fail. Or we will leave it to the market and we won't do anything. And that's easy as well. The hard one is to get it right and think fundamentally about the way in which Australia should be developing a suite of low energy technologies, recognising we will inevitably buy a lot of the technology we use. In some cases, it will be innovation. It won't be the fundamental research.
So do you think the government has got it wrong then with its... Well, the governments over the last, I suppose, 10 to 15 years have wanted to be technology neutral in terms of their their support by having generally non-technology specific funding programs. Is that the right way then?
It's the wrong way. And it's the wrong way in a particular way. When people think about governments picking winners, they're worried about governments picking losers. And the way it needs to work is a bit more like if you went to the races and you bet on the winner, that'd be cool, but most times you don't, at least I never do. So what you would tend to do is say, what I need to be able to do is bet on the field to start with, but as the race develops and I see which of the horses is beginning to get ahead, then I'll start to bet more of my money on those and take my money off those horses that are falling behind. And as the race gets towards the end, I keep doing that more and more, and ultimately I've got my money on the winner. Now that doesn't mean in the early part of the race I spent some money on horses that turned out to be losers, but what I've done is developed a way of thinking about developing the winners. And that's the sort of approach we need to use, and I don't see governments so far thinking about it that way.
I'll actually think about that as I go around talking to people in Canberra and trying to convince them to be more specific with their focus on how they do support technology development in the energy area. Gus, I'd like to ask you, Sam wanted to engage with society to understand its needs, and I know you very well, and so I know that you tried to do that also very well. But how do you engage and influence when you do the important heavy lifting in the laboratory and just through the way that you think about things, when society doesn't actually want to pay for what you're doing through increased energy prices? Ultimately, everybody is going to have to pay more for their energy through the imposition of the cost of addressing climate change and still getting that reliable energy. So how do you go about influencing people and getting them to understand the value of the work that you do?
Well, engaging, of course, is multifaceted, but working in industry and with industry is a critical way initially to identify what the problems are and getting involved with what the challenges that they're facing is the first step to helping to understand where the challenges are. So on one hand, this is a key part of making your research relevant. By the same token, engaging with public discussions, people in the audience will always ask the big picture question. Someone in there will ask a big picture question, which is too hard for you to answer initially, and then you have to start thinking about where it fits in the bigger picture. And I remember lots of those that have got me thinking. And then from our point of view as a centre, it's one of the reasons why we've also established the Industry Advisory Board, which of course Susan chairs, and that's been a critical role also in part of helping us as a centre to identify where the nexus between need and opportunity is. So returning back to your earlier question, I think from our perspective in Australia, we need to identify where the challenges and the opportunities are greatest in Australia, where the value is greatest. So, for example, where we have not much water, we have challenges in water, so there's greater value in solving those challenges. Australia's got a lot of unique circumstances where it would make more sense for us to invest in finding the solutions ourselves, and as such we can learn from that and export the knowledge.
Well, I'm still got mine. Well, this might be a good time then to see if there are any big picture questions in the audience. And there's a gentleman here who put up his hand very quickly. We're waiting for the microphone.
Experiment with this. So Canada has a company called Terrestrial Energy Inc. They have gotten funding, or they're looking for joint venture funding from the fracking miners in Alberta to build and to advance their design through the approval process of the through the approval process and through the manufacture of a in fact a factory manufacture of a first prototype, and other smaller nuclear 2.0 liquid-fueled nuclear reactors, and not for electricity but for the heat that the fracking miners actually need. They're going to stop burning natural gas, stop carting it up to wherever their mines are in remote Alberta, and replace that heat that they need, or produce that, with the output of a nuclear reactor that can be carted, the core can be carted on a truck. It's a smaller, modular, transportable nuclear reactor. They're doing it without all the government policy and negotiation. They're doing it with private sector funding. They are listening, and they're telling us that they're hearing the regulators saying, yes, this is a good idea. Lay a plan on our table that looks safe based on a successful experiment, the molten salt reactor experiment from the 60s at Oak Ridge National Laboratory. Now, there's an idea, has nothing to do with the big picture now, but I can see nuclear power coming and replacing the very fracking industry that is going to be funding this seed project. It'll save them money by bucket loads, but still be something that we should be looking forward to, because small, modular, transportable means cheap. I urge you to look at an app called Thorium Remix for iOS or Android, and play some of the documentaries, maybe 10 hours of documentaries that gives you a background that I can't tell you today.
Tony, do you see that's an option for Australia?
What do you know about it, and what can we expect once the Canadians have theirs in operation? But they're expecting 2021.
I guess the first thing I would say is that at some point we're going to have an adult conversation about nuclear energy in Australia. It doesn't seem like yet. I mean, and that's not to say that we should have, unconstrained rollout of nuclear power stations all over the country. I mean, the question is, what's the appropriate role for nuclear energy, and how can it be done safely and environmentally, etc. And I think the role of small nuclear reactors, or small modular reactors, is a really interesting one. In a piece of work that I talked about before, we did in 2012, we thought it would take about 25 years from now, from whenever you start, to be able to do anything on nuclear in Australia. And for those in the audience who don't know, it's actually illegal to produce electricity from nuclear energy in this country. So we've got a long way to go yet. I just think that at some point, I mean, it's unfortunate what happened in Fukushima, because I think the Labor Party was about to have a serious conversation about the role of nuclear energy in our energy mix. Unfortunately, that's been put back some way, and that may be a serious global setback for nuclear. But I'd certainly think we need to encourage a decent conversation about the topic. And
perhaps to add a couple of points, I think from Australia's perspective, or firstly from an energy perspective, uranium is the most energy-dense material. So globally, it doesn't really matter where the uranium is used. The transport of it is negligible in the energy terms. So a greater utilisation of uranium, if Australia is exporting and it's used, is still contributing to global reduction. In terms of your other point about smaller scale systems, is a very important one. The whole of the energy sector is undergoing a very rapid transformation towards probably smaller scale energy systems, both in decentralised but also in probably smaller scale, rather than in Australia is another example. We've got a lot of stretched grids, a lot of situations where it would make a lot more sense maybe to have a smaller locally located power supply system. This is also where Australia's technology, we can get a niche, get a big enough market at that scale to get technologies up and running, rather than trying to do very large-scale ones, which in Australia would be very hard for us to get a big enough local market to establish a new industry in that area. So there's lots of reasons why small-scale systems, if they start in a non-power-based system, doesn't really matter where they start. It's a good opportunity. So these kind of niches are where it's very important for new technologies to get up and running.
Okay, I might just point out, we've got a couple of rather significant national pioneers in the solar thermal industry in the audience, in Keith Lovegrove and Andrew Want. And Andrew, you want to ask a question?
Yeah, well, thank you very much, Susan. Privileged to be in such company as Keith, I have to say. But first, a short observation and then leading into a question. Just in relation to nuclear, Tony very eloquently explained before that one of the great challenges we're all facing now is the mispricing of externalities. In relation to nuclear, I cannot see how that is a problem that we can overcome. I do a lot of work in Japan, and it's very difficult to see how that society will turn back to nuclear. Germany is moving away from it for reasons that flowed from Fukushima. Why Australia would still be entertaining nuclear energy is frankly beyond me. I think it creates all sorts of the same questions for future generations that Tony talked about before. But that leads me into my question. Susan, I think I heard you say before that we'll all be paying more for energy as a result of a change to a zero carbon or low carbon environment. And I wanted to ask the speakers whether we really do think that's true, because I think we're seeing evidence of such rapid technological advances, PV being the most obvious example, that it's very, very likely the world is moving to a much more efficient energy platform based on solar. So I just wanted to get your comments about that.
I mean, like, the nuclear one, we'll have a conversation another time. Look, I think the part of the answer to the question is related to the first point you made, and that is, if we were truly costing the energy we produce from burning fossil fuels, then you might say we're already there. So that's the first point. I mean, while we continue to ignore the cost, the environmental cost of burning fossil fuels, then we will always have a significant distortion. And I think while that subsidy for fossil fuels sits there, it actually is very hard to see how we're going to get to the point. I mean, we all thought not that long ago that the world was going to run out of fossil fuels. Almost certainly it will not. It makes a much harder problem, of course. So, I mean, I am personally sceptical of those who say that solar is, you know, is already cheaper than grid, Now, in some ways, I don't care. I hope it is. What I want to make sure is that the policies and regulations that our government and other governments have in place both put a price on emissions and don't impede the sort of technological change you might be talking about that could lead to lower cost in the future. That's the important issue. I've got people come to me regularly saying, we've got this great technology, we think X is going to be cheaper than Y. As far as I'm concerned, most of it's at least most likely wrong. However, that's not the point. The real point is to make sure that we don't bet against those technologies, because I think what you said is quite possible. If it happens, that's great.
Perhaps on a similar note, I would say the path is the goal. So the challenge we have at the moment is how to transition our current system toward a lower emissions future at moderately low cost, which is the point that Tony made. So obviously I endorse everything you said, that it is potential in the longer term for them to be cheaper. But there also there are many costs in the transition process, because increasing intermittence, we have to learn better how to manage the variability. We don't know how much backup is needed in the system. There's a lot of uncertainties. Certainly offers potential for lower cost, and hopefully that'll happen in the longer term. The immediate challenge I see we need to face is how to identify the lower cost solutions that make sense in the Australian context, where we can be confident we can invest to bring emissions down with a low cost opportunity. So, and if we can identify the ones that make sense in the Australian context and engage with industry to do so, then the Australian industry can then learn where those niches, to get the value here, and then identify where those niches are also relevant in broader international context and play into that space. So I agree with your point. I think the focus for me is on the path.
Before you get the last question, Keith, there was one gentleman up here with his hand up. And we have about 2 minutes.
Thank you. I'll try to keep to the point and keep it short. So this is a question directed at Tony. So as you mentioned, the greatest point and the greatest challenge that we have is to create bipartisan policy support for a price on carbon to drive everything that we're talking about tonight. And as we have a government and leaders in this country that are becoming more and more reactionary towards the whims of the population and perhaps could be saying that they're policy followers and not policy leaders, what can we do as engineers, as members of the community, to try and convince the population that we want bipartisan support for a price on carbon?
On my good days, my optimistic days, look, I think you can get, when you see what's happened in the last little while, you can certainly get extraordinarily negative about the dog's breakfast we have in Australia on energy and climate policy. And we had a energy green paper published only a few weeks ago which sets out supposedly Australia's energy policy framework for the next several decades. And I think the word climate change is actually mentioned once. That's an example of the way this is now being politicised. However, I've got three sources of optimism. The first one is global pressure on whatever government's in power today. And you've seen evidence of that last week. Our current government has benefited enormously as a result of what happened with international terrorism recently, the stuff that's going on in the Middle East and in Ukraine. I think politicians also get it, that you can't be part of the global community on one hand and not the other. So there will be increasing pressure, and I think the real challenge will be what sort of commitments Australia makes in the lead up to the discussions next year. Now, it's not going to be trivial, it's not going to be beautiful, but hopefully it's somewhere in between. The second source of optimism I have is industry. Whether you like it or not, governments do listen to big industry. You only have to see the effectiveness of the Minerals Council in the way they manage to fight the minerals resource rent tax. I would suggest that already you are seeing large industry turning. When Obama and Xi Jinping made their announcement last week, the heads of both BHP Billiton and Rio Tinto both said, this is where we have to go, and carbon capture and storage is one way to get there. Now, you don't have to support the technology. The point is that industry is saying we need to move because we will be disadvantaged if we don't start to move. That's the third point of optimism, that industry will start to put serious pressure on our federal government. And the third point, which is probably the least pleasant source of optimism, is what happens if we have a really bad El Nino in the next couple of years, and to what extent the public concern about climate change will re-emerge as a significant pressure on government. So when I put those three together, I can see some real source of pressure on governments to change, and it's only when those sort of pressures arise that I think you will see change. And I think we'll see change. I think someone like Tony Abbott is actually has remarkable capacity to change given the right circumstances.
You have more better days than I do. Keith.
I'd like to end with what I hope is maybe slightly big picture. In the last week or two, with global leaders here and there, and China and India and whatnot, I've heard a bit more commentary about the prospect that there really could be a decreasing demand for Australia's coal exports. Question to both speakers, do you think this is likely, and if so, what should we do about it?
This month's IEA World Energy Outlook suggests that global coal growth by 2040 will still go up by about 15%. But of that 15%, 10 of that percent will happen in the next 10 years. What that says is its global growth in coal is going to be, the growth is going to be coming off quite rapidly for a whole range of reasons. And China will clearly, what it's decided to do will be part of that, because capping emissions by 2030 and capping coal consumption at a serious level is going to be very significant indeed. So I think there will be. What I conclude from that is this. Is there a future for coal? And the answer is yes, and there's no. The answer is no if we continue to try and burn coal the way we have in the past. The only answer that I can see is carbon capture and storage. Now, you don't have to be a believer in the technology or the cost of the technology, whatever. But if you accept the proposition as supposedly the leaders of the coal industry do, that the science of climate change is right, we have to move on it, and we have to meet the 2 degrees target, then you cannot burn all the coal we've got. The only way you can do that is carbon capture and storage, even to a degree, and the only way you fund carbon capture and storage is having a strong price on CO2 emissions. So the coal industry, my answer to your question is that the coal industry, rather than being fighting against putting a price on carbon, should actually be at the front of the queue cheering loudest to put a high price on carbon.
And just to add to that, I guess from my experience from engaging with various industry companies such as Foster Wheeler and the like are not investing as much in coal sector. They see those as decreasing in market opportunity, and they see the bigger ones in renewable energies or gas. So definitely the way industry is moving, it's clear that they're not anticipating big growth in coal consumption. They're seeing that as a dwindling sector. So observations would support that. And I also agree that carbon capture and storage is one of those technologies which has potential to play a role in the transition to a cleaner future. We don't quite know how big it'll be at the moment, but certainly I see the evidence is showing that, as you point out, interest in coal is dropping.
That was a subsequent question that you snuck in there quickly. We're 5 minutes late already.
Just a very quick comment I should have said before, and that is that growth I mentioned on coal is coming from a remarkably high base. I mean, the growth in coal consumption in the first decade of this century was absolutely extraordinary, and that's what's coming off. So even though the rate of growth is slowing, and therefore the rate at which people are going to put more money into new technologies in coal may be slowing, on those numbers, there's going to be an awful lot of coal around for an awful long time yet, and companies that can drive down low cost of coal development, whether you like it or not, I suspect are going to remain successful. The question is, can they be the source of their own destruction?
Perhaps one final comment, which you, as in the centre, would be aware, Australia still does have an opportunity to transform its fossil reserves. For example, coal is one of them, either by lowering the net carbon footprint rather than selling raw coal, but to generate cleaner fuels with coal as being a component in the mix. So it could be with adding concentrating solar or blending with biomass resources. Coal is still a cheap component, and these technologies could be transformed to use coal in the short term through to higher and higher fractions of alternative biomass feedstocks, which could be micro or macro algae into the future. But coal as a component in that mix can lower the cost of the exports while it's also generating lower net carbon footprints. So there are still opportunities for it to play a role into the future, especially if it's combined with carbon capture and storage. The key, my perspective, is that we need to identify low-cost pathways to low net carbon emissions and identify more or less technology-neutral pathways, whichever ones they may be, and participate in those, whether those be within the fuels being utilised internationally or whether we can be utilising them to add value in the Australian context.
Well, thank you, gentlemen, and I ask you to put your hands together for both Gus and Tony. Oh, you've
got one. Thank you, Susan, Tony, and Gus. Ladies and gentlemen, I think you will all agree with me that we have been served really well. This insightful, interesting, and really lively debate on energy. What we're hoping to do is to repeat this on a yearly basis. You are all invited to participate in this. And I have pledged for you from the Centre for Energy Technology that we determined to follow the path of Sam has inspired us to do, to innovate, to maintain excellence in everything we do, and most importantly, to make our work relevant and applicable to society both here in Australia and around the world. And I would like to invite you all to come with us on the journey by contributing to the university and to our centre, and for your patronage of this lecture in an annual basis. We look forward to seeing you all next year with another inspiring lecture on this so-called defining issue of our time. Thank you and good night.